everyone. In this video, we are going to solve the problem number 1.29 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. So a body is thrown from the surface of the earth at an angle alpha to the horizontal with the initial velocity v0, assuming the air drag to be negligible, and it is asking to find the time of the motion. So let us say this is x-axis, this is y-axis, which is representing the horizontal direction and the vertical direction respectively, and the body is thrown at an angle of alpha with the velocity of v0. So the initial velocity is equal to v0, okay, and the acceleration is in the negative y direction with the magnitude of g, that is acceleration due to gravity. Now if we talk about the equation of motion in 1D, equation of motion in 1D, then we can say, let us say if the acceleration is constant, then we are having three equations of motion. First equation of motion is displacement is equal to initial velocity into t plus half into acceleration t square. Second, we can write the final velocity is equal to initial velocity plus acceleration into t, and third we can write v square is equal to u square plus 2 times acceleration dot product with displacement. So these are the equation of motion we can write for the one dimensional case. Now if we talk about the two dimensional motion, then how can we apply this one dimensional equation? So for that we have to understand that motion in x direction and y direction both are independent to each other. So that means we can apply these equations of motion separately in the x direction and separately in the y direction, and then if we superimpose both the equations, we will get the combined motion. Now let us first write the initial velocity, that is given as, let us say, u vector is equal to v0 cos alpha I cap plus v0 sin alpha j cap, where I cap and j cap are the unit vectors along x and y direction respectively. So we can write the initial velocity is equal to ux I cap, which is representing the initial velocity in the x direction, and uy j cap, which is representing the initial velocity in the y direction. And the acceleration, let us write it as g vector is equal to minus g into j cap. Okay. Now in the first problem, it is asking to find the total time. So for that, let us analyze the motion of the body. Let us say this is x and y axis, and the body is starting from this particular point. Let us say this point is O, 0, 0, and it is following the parabolic path and it will go to this particular point. Let us say A, range, 0, or let us say x, 0. Okay. So the distance between O and A will represent the range. This is representing the range of the entire motion, and this particular distance is representing the maximum height. Okay. Now if we carefully look at here, the y coordinate has not changed from point A to point O. The y coordinate is not changing. That means the displacement in the y direction is equal to 0. If we apply the equation of motion in the y direction, then we can write Sy is equal to initial velocity in the y direction into t plus half into acceleration is in the negative y direction, so we can write minus g into t square. As the displacement is equal to 0, so we can write 0 is equal to initial velocity in the y direction is v0 sin alpha into t minus gt square by 2. So from here we can write V naught sine alpha into t is equal to gt square by 2. So from here we will get t is equal to 2 V naught sine alpha by g. So this is the value of total time we got. Let us represent it by capital T, that is equal to 2 V naught sine alpha by g. So this is the value of the total time we got. Now coming to the second part of the problem, it is asking to find the maximum height of the ascent and the horizontal range. Okay. Again, for the maximum height we have to apply the equation of motion in the y direction. So for maximum height we can apply another equations, b part. We can use v square is equal to u square plus 2as. Okay, so this equation we will apply. So let us say the velocity in the y direction is equal to initial velocity in the y direction plus 2 times acceleration is in the minus y direction, so we can write minus g into maximum height. Let us represent it by h. So if we carefully look at here, at this particular point, the velocity in the y direction is 0 and velocity in the x direction is equal to v naught cos alpha, because the body doesn't have the acceleration in the x direction, so the velocity will remain the same. So we can write here 0 is equal to initial velocity in the y direction is v naught sine alpha whole square minus 2gh. So from here we will get the maximum height is equal to v naught sine alpha whole square divided by 2g. So from here we will get maximum height is equal to v naught square by 2g times sine square alpha. So this is the value of maximum height we got. Now if we talk about the horizontal range, that is in the horizontal direction, so definitely for this we have to apply the equation of motion in the x direction. So for that we will use the equation of motion, that is displacement is equal to initial velocity into t plus half into acceleration into t square. So the total displacement we know that we can represent it by range is equal to initial velocity is ux into total time of flight, and acceleration in the horizontal direction is 0, so this term will be 0. Now we can write range is equal to what is the velocity in the x direction, that is v naught cos alpha. So we can write v naught cos alpha times what is the time of flight, that is 2 v naught sine alpha by g. So we can write 2 v naught sine alpha by g, and from here we will get v naught square into 2 sine alpha cos alpha by g, and 2 sine alpha cos alpha we know this is the sine 2 alpha. So finally the range we can write it as v naught square sine 2 alpha by g. Okay, so this is the value of range. Now in the third part of this problem, it is asking to find the angle at which both the maximum height and the horizontal range will be same. So let us equate both the equation. So we can write h is equal to range, and here h is v naught square by 2g into sine square alpha, v naught square by 2g into sine square alpha, that we can equate it to v naught square by g into sine 2 alpha. Okay, so v naught square by g and v naught square by g will get cancelled, and we will get the sine square alpha divided by g is equal to 2 sine alpha cos alpha, sorry not g, by 2. So from here we will get tan alpha is equal to 4, alpha is equal to tan inverse 4, so we can get 76 degree from here. So this is the angle at which if we project the body, then in that case the maximum height and the range will be same. Now coming to the third part, In the third part, it is asking to find the equation of trajectory y as a function of x, where y and x are the displacement of the body along the vertical and horizontal respectively. Okay, so let us talk about the C part. In the C part, let us say the displacement in the y direction is represented by y and the displacement in the x direction is represented by x. Now, let us write the y direction displacement, that we can write it as y is equal to initial velocity in the y direction into t minus half into g into t square, as the acceleration is in the negative y direction. Okay, and x we can write it as initial velocity in the x direction into t. Now, if we want to write the y as a function of x, we have to eliminate t from both the equation. For that, let us write t is equal to x divided by ux. Okay, and ux we can write it as v naught into cos alpha. Okay, so let us substitute the value of t in this particular expression. So from here we will get y is equal to uy into x divided by v naught cos alpha minus half into g into x square divided by v naught square cos square alpha. Okay, so we can write y is equal to uy is v naught sin alpha. So from here we will get x tan alpha minus g by 2 into x square whole divided by v naught square cos square alpha. So this is the expression of y, that is displacement in the y direction as a function of x we got. Now coming to the last part of the problem. In the last part, it is asking to find the curvature radii of the trajectory at its initial point and at its the peak. Okay, so first of all, let us write the formula for the radius of curvature. So the radius of curvature we can write it as 1 plus dy by dx whole square to the power 3 by 2 whole divided by d square y upon dx square. Now if we look at this particular function, doing the differentiation of twice and doing the square of that, it is a very tedious task to do, so we will use the different methodology to solve. So let us say this is x-axis, this is y-axis, and this is the projectile motion of the body. Now let us first talk about the highest point. At the highest point, the velocity is in this direction because the velocity in the vertical direction is 0, and let us say this is the curvature it is forming, and let us say this is the radius of the curvature. Now if we talk about in any circular motion, let us say if it is moving with a constant velocity, then and if the net force is acting towards the center and velocity is in this particular direction, so in this case we can write it as net force towards the center is equal to mv square by r, and r is what? The radius of curvature. So from here we can write r is equal to mv perpendicular whole square divided by force. So here force and velocity both are perpendicular to each other. Now here, what is the velocity in this direction at this point? The velocity is v naught cos alpha. Okay, and what is the force acting in this direction? That is mg always. Okay, so if we write the radius of curvature at the highest point, then we can write it as mv square divided by f. Okay, and here mv is equal to m times v naught square cos square alpha divided by mg. Okay, so will get cancelled, so we will get radius at the highest point, let us say hp, is equal to v naught square cos square alpha whole divided by g. So this is the value of the radius of curvature we got at the highest point. Now let us talk about the initial point. At the initial point, let us say this is the curvature it will form, and let us say this is the radius of curvature. In that case, at this particular point, the velocity is tangential to this circle. Velocity is tangential to this circle, and we know the value of this velocity is v0. Okay, and if we talk about the force, mg is acting in this direction. Mg is acting in this direction, and we know this particular angle is alpha. So this angle will be 90 minus alpha. So this angle will be alpha. Now if we talk about the force in this particular direction towards the center, then we can write it as, if we take the component of mg in this direction, then we will get mg times cos alpha. Now we can write the radius of curvature at the initial point. Let us denote it as IP. That we can write it as mv squared by f. Okay, so m times velocity in this direction is v0, which is perpendicular to the force. That we can write it as v0 square whole divided by force is mg cos alpha. So from here we will get the radius of curvature at the initial point is equal to v0 square divided by g times cos alpha. Okay, so this is the expression we got for the radius of curvature at the initial point. Okay, so this is the methodology we can use to find the radius of curvature in any curvilinear motion. Okay, either you can also use this if the y as a function of x is simple. Okay, so I hope the entire procedure is clear. Thank you.